Good morning, friends. Welcome to online classes from MGVC Arts, Commerce and Science College, Muddi Bihar. It's Department of Chemistry, and myself, UMARFAROOQ HALYAL. I am today going to take for your BSc 5th Sem class in that Chemistry Paper 2, and this is the continuation of the unit Industrial Chemistry Part 1 in that abrasives. In previous class you already discussed about the manufacture and applications of carborundum, and along with that manufacture and applications of alundum, and also we discussed regarding to Mohs hardness of scale. And today we are going to discussing about manufacture and applications of tungsten carbide. So this tungsten carbide, it is an inorganic chemical compound that containing equal parts of tungsten and carbon atoms. Here tungsten carbide means it is an inorganic chemical compound so that containing equal parts of tungsten and carbon atoms. So again we have to see what is tungsten carbide. It is a ceramic material, and so this tungsten carbide is a refractory metal with the highest melting temperature at 3410 degrees Celsius, or else in some other cases we have mention the different one, and the noob hardness is around 2100. The mixture of the two reduces cost for tools, and this is the tungsten carbide milling bits. So these bits are made up of tungsten carbides. Where we use, can anyone guess? So these bits we are using in to get the hole in doors or walls or windows by a machine. Here the chemical formula for tungsten carbide is Wc, and the molar mass of this tungsten carbide is 195.85 gram per mole. Here appearance, this is grey black lustrous solid, and density 15.63 gram per cubic centimeter, and melting point is about 2785 to 2830 degree Celsius, or in we have Fahrenheit, that is 5045 to 5126 degree Fahrenheit. When we convert that is in the Kelvin meter, the melting point of this tungsten carbide is 3058 to 3103 Kelvin. And when we coming for the boiling point, it is about approximately 6000 degrees Celsius. That is a very huge amount of temperature. When this is in the Fahrenheit unit, that is 10,830 Fahrenheit. When it is converted into in the Kelvin range or Kelvin scale, the boiling point of this tungsten carbide is 6270 Kelvin at 760 millimeter of mercury. So solubility in water, no, that is insoluble in water, and this tungsten carbide is soluble in nitric acid, hydrogen fluoride, that is HNO3 and HF, and the magnetic susceptibility that we call X, that is 1.10⁻⁵ cubic centimeter per mole. This is the property. And when we coming for production, We can be prepared by reaction of tungsten metal and carbon at the range of 1400 degrees Celsius to 2000 degree Celsius. Or other methods includes a patented lower temperature fluid bed process that reacts either tungsten metal or blue WO3, that is tungsten oxide with carbon monoxide or carbon dioxide mixture and hydrogen between 900 and 1200 degrees Celsius. Here, mainly our tungsten carbide is prepared by the reaction of the tungsten metal and carbon at 1400 to 2000 degrees Celsius. That means W plus C giving us to WC. That is the main process. These are the some different processes. And here next we coming. Here the tungsten carbide can also be produced by heating tungsten oxide with graphite directly at 900 degrees Celsius or in hydrogen at 670 degrees Celsius, following by carburization in argon at 1000 degrees Celsius. Here chemical vapor deposition methods we have to investigate it. Then after reacting tungsten hexachloride with hydrogen as a reducing agent and methane as the source of carbon at 670 degrees Celsius or 1238 degree Fahrenheit, we got tungsten carbide. See the reaction. Tungsten hexachloride, that is WCl6 plus hydrogen, that is H2, and methane CH4. Here methane acts as a reducing agent. WCl6 plus H2 plus CH4, that gives us our tungsten carbide, that is WC plus 6HCl. That's the main reaction. In other words, again that tungsten hexafluoride is reacting with hydrogen as reducing agent and methanol as a source of carbon at 350 degrees Celsius or 662 degree Fahrenheit. WF6 plus 2H2 plus CH3OH means WF6 is tungsten hexafluoride plus 2 molecules of hydrogen, that is here role as a reducing agent, and plus CH3OH, that is methanol, that gives us WC, that is our tungsten carbide plus 6 molecule of HF, hydrogen fluoride plus H2O. This is the production method. Sorry, got this? Here first process, tungsten hexafluoride is reacting with hydrogen and reacting with methane, that gives us tungsten carbide. In the again second process, the tungsten hexafluoride is reacting with hydrogen and methanol, that gives us our tungsten carbide. Now when we coming for the applications of this tungsten carbide, so this tungsten carbide is great attracted by the engineers, academics for the sake of their excellent properties such as hard and wear resistance, and it is having high melting point and chemically inert. It has been applied in numerous important industries including aerospace, oil and gas, automotive, semiconductor, marine, mining and cutting tools and molding of different dyes, etc. There are a lot of uses are there this tungsten carbide. Here this tungsten carbide we are extensively using in manufacturing of cutting tools. Just I show that the beginning of this topic, that is drill bits. that tungsten carbide milling bits where we are using we are using in drilling machines. Then next one, extreme hardness and good wear resistance. First, this is used in machining operations as lathe cutting tools, and majority are single point cutting tools used on lathes and milling machines. And when we coming for mining and foundation of drilling, this tungsten carbide is used extensively in mining in top hammer rock drill bits. See that pic? A tricone roller cone assembly from a raise boring reamer showing the protruding tungsten carbide buttons inside the rollers. Then this tungsten carbide is also used in jewelry. So tungsten carbide, typically in the form of a cemented carbide, that means carbide particles brushed together metals, has become a popular material in bridal jewelry industries due to its extreme hardness and high resistance to scratching. Even with high impact resistance, this extreme hardness also means that it can occasionally be shattered under certain circumstances, and some consider this is useful since an impact would shatter a tungsten ring quickly by removing it, where precious metals would bend flat and require cutting. And this tungsten carbide is roughly 10 times harder than 18 karat gold. In addition to its design and high polish, part of its attraction to other metals. So this tungsten carbide we are using also in jewelries because of their hardness. As we know that this tungsten carbide is roughly 10 times harder than that 18 karat gold. Okay, so this is enough for today's class. You go through this video and please subscribe my YouTube channel, each and every one student, for getting your regular class videos. And in the next class I am going to discussing the next bit of the same industrial chemistry part 1, that the next topic is glass. So still that, stay at home, stay safe and enjoy the classes. Thank you.